USB 3.0 is the third major version of the Universal Serial Bus Standard for computer connectivity. Among other improvements, USB 3.0 adds a new transfer mode called SuperSpeed, capable of transferring data at up to 5 Gbps, which is more than 10 times as fast as the 418 bits high speed of USB 2.0. Beside different connectors used on USB 3.0 cables, they are also distinguishable from their 2.0 counterparts by either the blue color of the ports or the SS initials on the plugs. A successor standard named USB 3.1 was released in July 2013, providing transfer rates up to 10 Gbps, which effectively put it on par with the first version of Thunderbolt. Differences in comparison to USB 2.0. The USB 3.0 specification is similar to USB 2.0 but with many improvements and an alternative implementation. Earlier USB concepts like endpoints and 4 transfer types are preserved but the protocol and electrical interface are different. The specification defines a physically separate channel to carry USB 3.0 traffic. The changes in this specification make improvements in the following areas. Transfer speed added a new transfer type called SuperSpeed or SS, 5 Gbps, increased bandwidth or instead of one-way communication. USB 3.0 uses 2 unidirectional data paths, one to receive data and the other to transmit. Power management UO through U3 link power management states are defined. Improved bus utilization a new feature is added to let a device asynchronously notify the host of its readiness. Support to rotating media bulk protocol is updated with a new feature called Stream Protocol that allows a large number of logical streams within an endpoint. USB 3.0 has transmission speeds of up to 5 Gbps, which is 10 times as fast as USB 2.0 before taking into account that USB 3.0 is full duplex whereas USB 2.0 is half duplex, giving USB 3.0 the potential total bandwidth if utilized both ways to 20 times that of USB 2.0. Architecture and features. In USB 3.0, dual-bus architecture is used to allow both USB 2.0 and USB 3.0 operations to take place simultaneously, thus providing backward compatibility. Connections are such that they also permit forward compatibility, that is, running USB 3.0 devices on USB 2.0 ports. The structural topology is the same, consisting of a tiered star topology with a root hub at level 0 and hubs at lower levels to provide bus connectivity to devices. Data transfer and synchronization. The SuperSpeed transaction is initiated by the host making a request followed by a response from the device. The device either accepts the request or rejects it. If accepted, then device sends data or accepts data from the host. If the endpoint is halted, the device shall respond with a stall handshake. If there is lack of buffer space or data, it responds with a not ready signal to tell the host that it is not able to process the request. When the device is ready, then, it will send an endpoint ready to the host which will then reschedule the transaction. The use of unicasting and the limited multicasting of packets, combined with asynchronous notifications, enables links that are not actively passing packets to be put into reduced power states, allowing for better power management. Data encoding. The SuperSpeed bus provides for a transfer mode at a nominal rate of 5.0 Gbps, in addition to the 3 existing transfer modes. Accounting for encoding overhead, the raw data throughput is 4 Gbps, and the specification considers it reasonable to achieve 3.2 Gbps or more in practice. All data is sent as a stream of 8 bits which are scrambled and then converted into a 10-bit format. This helps to reduce electromagnetic interference. The inverse process is carried out at the receiving end. Scrambling is implemented using a free-running linear feedback shift register. The LFSR is reset whenever a comms symbol is sent or received. Unlike previous standards, the USB 3.0 standard does not directly specify a maximum cable length, requiring only that all cables meet an electrical specification. For copper cabling with 26 Reuben Florins wires, the maximum practical length is 3 meters. Availability. The USB 3.0 Promoter Group announced on November 17, 2008 that the specification of version 3.0 had been completed and had made the transition to the USB implementers. Euro Unregistered Trademark Forum, the managing body of USB specifications. This move effectively opened a specification to hardware developers for implementation in future products. The first USB 3.0 consumer products were announced and shipped by Buffalo Technology in November 2009, while the first certified USB 3.0 consumer products were announced January 5, 2010, at the Las Vegas Consumer Electronics Show, including 2 motherboards by ASUS and Gigabyte Technology. Manufacturers of USB 3.0 host controllers include, but are not limited to, Renesas Electronics, Fresco Logic, ASMedia Technology, Tron, VIA Technologies, Texas Instruments, NEC and NVIDIA. As of November 2010, Renesas and Fresco Logic have passed USB-IF certification. Motherboards for Intel Sandy Bridge processors have been seen with ASMedia and Tron host controllers as well. On October 28, 2010, Hewlett-Packard released the HP NV17 3D featuring a Renesas USB 3.0 host controller several months before some of their competitors. AMD worked with Renesas to add its USB 3.0 implementation into its chipsets for its 2011 platforms. At CES 2011, Toshiba unveiled a laptop called Toshiba Cosmio 10500 that included USB 3.0 and Bluetooth 3.0, and Sony released a new series of Sony VAIO laptops that will include USB 3.0. As of April 2011, the Inspiron and Dell XPS series are available with USB 3.0 ports, and, as of May 2012, the Dell Latitude laptop series, yet the USB root hosts fail to work at super speed under Windows 8. On June 11, 2012, Apple announced new MacBook Airs and MacBook Pro with USB 3.0. Adding to existing equipment. In laptop computers that lack USB 3.0 ports but have an Express card slot, USB 3.0 ports can be added by using an Express card to USB 3.0 adapter. Although the Express card port itself is powered from a 3.3 AV line, the connector also has an USB 2.0 port available to it. However, this USB 2.0 port is only capable of supplying the power for one USB 3.0 port. Where multiple ports are provided on the Express card, additional power will need to be provided. Additional power for multiple ports on a laptop PC may be derived in the following ways. Some Express card to USB 3.0 adapters may connect by a cable to an additional USB 2.0 port on the computer, which supplies additional power. The Express card may have a socket for an external power supply. If the external device has an appropriate connector, it can be powered by an external power supply. USB 3.0 port provided by an Express card to USB 3.0 adapter may be connected to a separately powered USB 3.0 hub, with external devices connected to that USB 3.0 hub. On the motherboards of desktop PCs which have PCI Express slots, USB 3.0's support can be added as a PCI Express expansion card. In addition to an empty PCIe slot on the motherboard, many PCI Express to USB 3.0 expansion cards must be connected to a power supply such as a Molex adapter or external power supply, in order to power many USB 3.0 devices such as mobile phones, or external hard drives that have no power source other than USB. As of 2011, this is often used to supply 2 to 4 USB 3.0 ports with the full 0.9 AA of power that each USB 3.0 port is capable of, whereas the PCI Express slot itself cannot supply the 0.9 AA. If faster connections to storage devices are the reason to consider USB 3.0, an alternative is to use instead storage devices using eSATA and add an inexpensive bracket adding an eSATA port to the motherboard. Some external drives support both USB and eSATA with an exchangeable adapter, so the same drive can be used with an USB 3.0 laptop. To ensure compatibility between motherboards and peripherals, all USB-certified devices must be approved by the USB Implementers Forum. At least one complete end-to-end test system for USB 3.0 designers is on the market. Adoption. The USB Promoter Group announced the release of USB 3.0 on November 2008. On January 5, 2010, USB-IF announced the first two certified USB 3.0 motherboards, one by Asus and one by Gigabyte. Previous announcements included Gigabyte's October 2009 list of 7P55 chipset USB 3.0 motherboards, and an ASUS motherboard that was cancelled before production. Commercial controllers were expected to enter into volume production in the first quarter of 2010. On September 14, 2009, Freecom announced a USB 3.0 external hard drive. On January 4, 2010, Seagate announced a small portable HDD bundled with an additional USB 3.0 Express card, targeted for laptops at the CES in Las Vegas, Nevada. The Linux kernel has supported USB 3.0 since version 2.6.31, which was released in September 2009. Windows 8 was the first Microsoft operating system to offer built-in support for USB 3.0. Drivers are under development for Windows 7, but support was not included with the initial release of the operating system. However, drivers that enable support for Windows 7 are available through websites of hardware manufacturers. Intel released its first chipset with integrated USB 3.0 ports in 2012 with the release of the Panther Point chipset. Some industry analysts have claimed that Intel was slow to integrate USB 3.0 into the chipset, thus slowing mainstream adoption. These delays may be due to problems in the CMOS manufacturing process, a focus to advance the Nehalem platform, a way to mature all the 3.0 connections standards before developing a new chipset, or a tactic by Intel to favor its new Thunderbolt interface. Apple Incorporated announced laptops with USB 3.0 ports on June 11, 2012, nearly 4 years after USB 3.0 was finalized. AMD began supporting USB 3.0 with its Fusion controller hubs in 2011. Samsung Electronics announced support of USB 3.0 with its ARM-based Exynos 5 dual platform intended for handheld devices. Speed and compatibility issues. Early versions of the widely used NEC Renesas or Micron D72020X family of host controllers are known to require a firmware update to function properly with some devices. All major test equipment vendors offer tools for testing devices and cables against USB 3.0 electrical compliance requirements. Electrical testing requires an USB 3.0 test board providing Type A, B, or Mini-AB electrical compliance test breakout adapters. A factor affecting the speed of USB storage devices is that the USB mass storage bulk-only transfer protocol drivers are generally slower than the USB-attached SCSI protocol drivers. On some old Ibex PEEK-based motherboards, the built-in USB 3.0 chipsets are connected by default via a 2.5 GTS PCI Express lane of the PCH, which back then did not provide full PCI Express 2.0 speed, so it did not provide enough bandwidth even for a single USB 3.0 port. Early versions of such boards have a manual switch that can connect the USB 3.0 chip to the processor, which did provide full-speed PCI Express 2.0 connectivity even back then, but this meant using fewer PCI Express 2.0 lanes for the graphics card. However, newer boards used a channel bonding technique that combines two PCI Express 2.5 GTS lanes into a single PCI Express 5 GTS lane, thus obtaining the necessary bandwidth from the PCH. Radio frequency interference. USB 3.0 devices and cables may interfere with wireless devices operating in the 2.4 GHz ISM band. This may result in a drop in throughput or complete loss of response with Bluetooth and Wi-Fi devices. Various strategies can be applied to resolve the problem, ranging from simple solutions such as increasing the distance of USB 3.0 devices from Wi-Fi routers and Bluetooth devices, to applying additional shielding around internal computer components. Connectors. An USB 3.0 standard A receptacle accepts either a USB 3.0 standard A plug or a USB 2.0 standard A plug. Conversely, it is possible to plug a USB 3.0 standard A plug into a USB 2.0 standard A receptacle. Similar principle of backwards compatibility applies to connecting a USB 2.0 standard A plug into a USB 3.0 standard A receptacle. The standard A is used for connecting to a computer port, at the host side. An USB 3.0 standard B receptacle accepts either a USB 3.0 standard B plug or a USB 2.0 standard B plug. Backwards compatibility applies to connecting a USB 2.0 standard B plug into a USB 3.0 standard B receptacle. Though, it is not possible to plug a USB 3.0 standard B plug into a USB 2.0 standard B receptacle, due to a physically larger connector. The standard B is used at the device side. Since USB 2.0 and USB 3.0 ports may coexist on the same machine and they look similar, USB 3.0 specification mandates appropriate color coding and recommends that the standard A USB 3.0 connector has a blue insert. The same color coding applies to the USB 3.0 standard A plug. USB 3.0 also introduced a new micro B cable plug, which consists of a standard USB 1X/2.0 micro B cable plug, with additional 5-pin plugs stacked on side of it. That way, USB 3.0 micro A host connector preserved its backwards compatibility with the USB 1X/2.0 micro B cable plugs. Though, it is not possible to plug a USB 3.0 micro B plug into a USB 2.0 micro B receptacle, due to a physically larger connector. Pinouts: the connector has the same physical configuration as its predecessor but with 5 more pins. The VBUS, DA, D+, and GND pins are required for USB 2.0 communication. The additional USB 3.0 pins are 2 differential pairs and 1 ground. The 2 additional differential pairs are for superspeed data transfer. They are used for dual simplex superspeed signaling. The GND drain pin is for drain wire termination and to control ME and maintain signal integrity. Backward compatibility: Type A plugs and receptacles from both USB 3.0 and USB 2.0 are designed to interoperate. Type B receptacles in USB 3.0 are somewhat larger than would be required for a Type B plug in USB 2.0 and earlier. The larger dimension for a USB 3.0 Type B receptacle is intended to allow connecting of either the larger USB 3.0 Type B plug or the smaller USB 2.0 or earlier Type B plug into a newer USB 3.0 Type B receptacle. Accordingly, a USB 3.0 Type B receptacle on a peripheral device can be connected using the corresponding plug end of a USB 2.0 Type B cable. Type B plugs in USB 3.0 are somewhat larger. Therefore, a USB 3.0 Type B plug cannot enter a USB 2.0 or earlier Type B receptacle. Accordingly, normal USB 3.0 Type B plugs cannot be inserted into normal USB 2.0 Type B receptacles found on peripheral devices. A receptacle for eSATA is designed to accept USB Type A plugs from USB 2.0 and USB 3.0. See also, Computer Bus, List of computer peripheral bus bit rates, Extensible Host Controller Interface, Mobile High Definition Link, References. External links: USB 3.0 Standard A, Standard B, Powered B connectors Pinouts, pinoutsguide.com. Supreme Port, 4 huge changes coming to USB, laptopmag.com. AAA Euro CES 2014 report of a laptop docking port using a single USB 3.1 port to supply power, video and USB peripherals.